right, so today we're going to move on and continue talking about inequalities, but we're going to solve some inequalities. So the same way we solved equations, we will use those same strategies for solving inequalities. Same way we started with one-step equations, we're going to start with one-step inequalities. So solving inequalities using addition or subtraction. Adding or subtracting the same number on each side of an inequality will produce an equivalent inequality, meaning we can do this. We can add the same number to both sides of an inequality. We can subtract the same number from both sides of an inequality, and it will continue to stay true. Solving inequalities has a similar process as solving equations. Just instead of an equal sign, you will have the inequality. We're going to show our work algebraically just like we did before. So just like we did before, we're going to highlight the side of the inequality that has the variable. So b minus 7, the inverse or the opposite of subtracting 7 would be to add 7 on both sides. Now remember, some people were drawing a line through the equal sign. You can still do that if you need to. So the minus 7 plus 7 is worth 0, and I would have b is less than or equal to the negative 1 plus 7. I have more positives than negatives, so it would be 6. B is less than or equal to 6, and I'd be done. That would be my solution. All values less than or equal to 6 will make the original inequality true. So if you wanted to go plug in b is 0, 0 take away 7 would come out less than or equal to negative 1, and it would be a true statement. B equals 0 would be a solution. On the next one, we're going to highlight the side of the variable y plus 10. The inverse, or opposite of plus 10 would be minus 10 on the right, minus 10 on the left side of the inequality. So plus 10 minus 10 is 0. 3 take away 10 would be negative 7 is greater than y. We're never going to leave our answer with the y on the right side. The variable should always come first or be on the left. So y, the small part of the symbol is next to the y, so we're going to keep the small part of the symbol next to the y. Y is less than negative 7. You can put a circle around it so you know which one's the final one. That helps for some people. On the next one, c plus 1.5 is the side with the variable. So the opposite of adding 1.5 would be subtracting 1.5. And if I have 2 take away 1.5, I would have a half is less than or equal to c. Not going to leave the variable on the right. I'm going to move the variable over to the left. The greater than part, the open part of the circle, the open part of the symbol is next to the c, so it's going to stay there when I flip it over, and 1/2. And last but not least, decimals work as well. If I have a variable on the right, I highlight the right side, k minus 3.7, I'm going to do the inverse, which is add 3.7 on the right, add 3.7 on the left. Now, you might go, oh, negative 4.6, positive 3.7. I don't know what that is quickly off the top of my head and accurately. One is positive and one is negative, which means I need to find the difference. So off to the side, I might do 4.6 take away 3.7. I might have to borrow from the 4. 16 take away 7 is 9. 3 take away 3 is 0. 0.9. I'm going to look at the original. There were 4.6 negatives, only 3.7 positives. So there were more negatives. So it's negative 0.9 is less than k. Not going to leave the variable on the right, going to move it over to the left. Big open part was next to the k, so the big open part stays next to the k, negative 0.9. Do not try to shortcut this. There are going to be times where you have a mix of positives and negatives, and you need to just do the work off to the side, the same as when it was an equation. Now let's look at some relationships with multiplying and dividing. So let's say we wanted to do 2x is greater than 6. What do you predict the solution will be? What do we think? Well, most of the time we would think we divide the left side by 2, divide the right side by 2. X is going to be numbers greater than 3. So we would think anything greater than 3 would make this true. So if I plug in negative 1 for x, okay, if I do 2 times negative 1, I would get negative 2. Is that greater than 6? Nope. 2 times 0 is 0. Is that greater than 6? Nope. 2 times 1 is 2. Is that greater than 6? Nope. 2 times 2 is 4. Is that greater than 6? Nope. 3 times 2 is 6. Is 6 greater than 6? No. 2 times 4 is 8. Yes, that is greater than 6. 2 times 5 is 10. Yes, that is greater than 6. 2 times 6 is 12. Yes, that is greater than 6. Even if I were to jump in here and pick a number like 3.5, if I did 2 times 3.5, I would get 7, and that would be a yes. So numbers greater than 3, 3.5, 4, 5, 6, any of those numbers greater than 3, when I plug them in, I do in fact get a number greater than 6. So our prediction was correct. Now, what about an inequality like negative 4x is greater than 12? Now, most of the time, we would sort of jump on this and be like, oh, it must be, let's see, x is greater than, if I divide both sides by negative 4, I get negative 3. X is greater than negative 3. So x is greater than negative 3 is going to be my prediction. So if I do negative 4 times negative, I was going to plug in negative 6. Negative 4 times negative 6, I get 24. Is 24 greater than 12? And we would say yes. Negative 4 times negative 5 is 20. Is that greater than 12? Yes. Negative 4 times negative 4 is 16. Is that greater than 12? Yes. Negative 4 times negative 3 is 12. And we would say that's a no because they're actually equal and not greater than. And so all of the rest of these are also no. Now, we thought x greater than negative 3 was going to work. And what we found was that all these numbers greater than negative 3 did not work. It was actually the numbers less than negative 3 that worked. So our prediction was not correct. What was the difference between the two inequalities? Well, the first one, you'll notice, didn't have any negatives in it, and the second one did have a negative. So there was a negative multiplied by the variable. And we can say that that sort of, it made our results opposite what we thought they would be. So the results were not consistent. You know, we didn't get what we thought we would get when that negative was in there. What predictions can you make about inequalities that involve multiplying or dividing? Well, when we multiply or divide, and this is going to be really important. When we multiply, I can't write apparently. When we multiply or divide both sides by a negative, the results will be opposite. Now, in order to fix that, what we do is we flip the inequality symbol. And I'll show you on the back how that works. We'll flip the inequality symbol. So if we flip our paper over, you can see solving inequalities using multiplication or division, multiplying or dividing each side of an inequality by the same positive number produces an equivalent. However, the second line, multiplying or dividing each side of an inequality by the same negative number and reversing the direction of the inequality symbol will produce an equivalent inequality. So what I'm going to do is I'm going to go through on all of the ones on the back, and I'm going to highlight the side with the variable. So I'm going to highlight the side with the variable, and I'm highlighting all of the ones where the side of the variable has a positive number, okay? So you'll notice 3x, if I divide both sides by 3, I get x is greater than negative 5, and I'm done. And that's because the number on the side of the variable was positive. Same thing here. This is y divided by 3. I'm going to multiply the left side by 3. I'm going to multiply the right side by 3. I'm going to get y is less than or equal to negative 3. The number on the side with the variable was positive. 7w is greater than or equal to 22. Divide by 7, divide by 7. W is greater than or equal to. Now you can leave this as 22/7. You can also do 3 and 1/7. They're both going to work. But the thing that matters here is that the number on the side of the variable was positive. So all of those straightforward, no big deal. When you get a variable and a negative number with the variable, that's when you have to remember sort of that bonus step. And I will do those all together. So negative 4y, that's multiplication. So I'm going to divide by negative 4. divide by -4. So over here they cancel. Nothing is different from what we've done before, except this time I'm going to have to flip that greater than symbol to a less than symbol, specifically because I divided both sides by a negative. So when I divide both sides by a negative, I have to flip that greater than became a less than. So we'll do the same thing here. I'm going to divide both sides by -8. I'm going to get -2 instead of less than. It's going to become greater than y. I divided both sides by -8. Everything came down, right? 16 divided by -8 is -2. I only have the y on the right side. The less than became a greater than. And this is one where I have to say, oh, can't leave the y on the right. Have to remember to switch it so the variable is on the left. So if the variable does not come out on the left, you do need to do an extra step. So on this one, I had to flip from a less than to a greater than, and then eventually change my answer so the variable was on the left. All right, now this one's a fraction, and in order to solve a fraction multiplication, we need to use the reciprocal. That should sound familiar at least. Multiply by -5/4. It's the fraction flipped over. Notice they're still both negatives, so I want them to cancel. And over here, I'm going to do -5/4. So on the right, everything cancels, and I did that on purpose. Because I multiplied both sides by a negative, that greater than has got to become a less than. And then over here, this 4 would cancel this 4. Negative times a negative would become a positive. And then I would rewrite so that the variable is on the left with the big part of the symbol next to the X. So lots of little steps from the earlier units showing up again. All of the algebra, showing our work algebraically, remembering our multiplying by fractions, remembering multiplying by positives and negatives, all those things that we worked so hard for in trimester 1, coming back up again in trimester 2. Now, this one sometimes throws people for a loop because they don't see the negative as being assigned anywhere. You can rewrite it so that that negative sign goes with the 2, and that helps a lot of people because now you can see it as y divided by -2. Going to multiply the left by -2. Going to multiply the right by -2. Because I multiplied both sides by a negative, that greater than or equal to flips to a less than or equal to. 3 times -2 is -6. And last but not least, I cannot solve this one with a mixed number. I'm going to have to write that as -5/3 w less than or equal to -10. All I did was 3 times 1 is 3, plus the extra 2 is 5/3. It was -1 2/3. It's still -5/3. This is a negative fraction. Again, we're going to use the reciprocal. Times -3/5 times -3/5. Look to see if there's any simplifying. Sure is. The 5 and the 10 can simplify. And, I multiply by a negative, so that's got to become a greater than instead of a less than. -2 times -3 is 6. So this is where I had to flip the symbol because I multiplied both sides by a negative, and I can even clean that up. Now, you might also at some point be asked to graph a solution. So you might solve an inequality and also graph the solution. And those are going to look just like they did in part 2. So for example, if you wanted to graph y is less than or equal to -6, you'd put the -6 in the middle, bigger numbers to the right, smaller numbers to the left, closed circle on -6 because it's got the equal to. Y is less than or equal to -6, I would point my arrow towards the left, towards the smaller numbers. This one is W is greater than or equal to 6. So I would put my 6 in the middle, bigger numbers to the right, smaller numbers to the left. The 6 would get a closed circle as well because it has the equal to. Greater than or equal to 6, I would point my arrow towards the values that are larger or greater than 6. So you do need to read the directions when you're doing problems like this to see if they only want you to solve it or if they want you to solve it and graph it. So just a quick little refresher on the graphing as well. Probably going to be lots of questions on this just because we're reviewing a lot of topics, reciprocal of fractions, multiplying and dividing with negatives. And don't forget to flip the inequality if you multiply or divide both sides by a negative.